Okay, good morning. So please, Joseph, if you want to introduce.
Hello, everyone. I'm Joseph, and I want to welcome you all to this workshop on global partnerships for sustainable construction and resource efficiency. The workshop is being held in collaboration with the University of Padua, and my co-host is Luca Valentini. I will invite Duta Wabura to give a few highlights on Erasmus. And Anne Duta is the Erasmus program is a European Union program that is basically support education training and sports in Europe. And I will welcome Duta to give us a few highlights on this. Welcome, Duta.
Thank you, everybody. Thank you so much for joining into this workshop. I don't know where you are. Good morning, good afternoon, good evening, wherever you are in this world. My name is Nduta Wambura. I'm the country representative for Kenya, and I hope that we have a very energetic day today because it's going to be a long one, Luca. And so, anyways, my name is Nduta Wambura. Like I mentioned, I am the country representative for Kenya for Erasmus Plus. And just like Joseph mentioned here, Erasmus Plus is a European Union program that supports education, training, youth, and sports in Europe, pretty much globally. And over the years, we have seen quite a number of people being beneficiaries of the program. I'm personally a beneficiary of the Erasmus program, having studied my Erasmus Mundus joint master's degree, and I currently live in Lisbon, Portugal. So now we have an exciting time right now because we just rolled out an estimated budget of about 26.2 billion euros for the phase beginning 2021 to 2027. So this is quite an exciting time because it will mean that we will have a huge focus on social inclusion. We'll have a huge focus on students coming to study in Europe, and in this case with a focus definitely with Kenya. So I would encourage pretty much anyone to actually go ahead and apply for an Erasmus Mundus joint master's program. And it is with great pleasure that I am happy to see that this partnership between Meru University and the University of Padua, I'm sure I'm saying that wrong because of course it's in Italian, and I do hope to see quite a number of students coming in to join the program and benefit from studying in Europe. The European education system is not just about study, it's about you ensuring that you can see the culture and benchmark within Europe. And definitely I am with the European delegation on this one because we tend to do quite a lot with them in terms of sensitizing students to actually apply for programs to come and study in Europe. So we do have quite a number of cooperations and partnerships already happening in different universities other than the Meru University. So please ensure that you can definitely share this information also with someone else who can benefit from it. So mine will be quite short. I want to say that Erasmus Plus in Kenya, how you can benefit from this is to definitely apply for a Erasmus Masters Joint Program. And these applications would be open between September of this year all the way to March of next year. So you do have quite a bit of time to give yourself, some time to study the program that you want to actually join, know the requirements, prepare early, start the application for you to begin your study in September of 2022. And I am so excited to see this partnership because this would possibly be the same connotation whereby you apply, come to Europe, study, benchmark, be able to enjoy the culture, travel around, open up your mind because this is something that is available to you. So I would like to leave you with words of encouragement that this can also be for you. I'm personally a beneficiary of the Erasmus program, having come from my alma mater, Kenyatta University, and I have benefited from it. I represent the association currently, and I would like to actually invite you. In fact, my role as a country representative is incomplete if I do not invite you to join the Erasmus Mundus Association Kenyan chapter social platform on Facebook. For more updates, I would definitely leave a link on the chat right now. So, like I mentioned, notably, the applications for the Erasmus Joint Master's Degree programs will reopen in September with an application period that runs up until March, depending on the program, which gives you quite the ample time to begin preparing as soon as now to meet the required deadline. So as I join hands with the European delegation in Kenya, so sorry that they could not come in today, I would like to thank Luca and Joseph for making this happen, and I cannot wait to see the beneficiaries of this program. So without much further ado, welcome, welcome, welcome. Brace yourself, get that coffee for this fantastic workshop that is coming up today, and take all the notes, record what you need to record, and tell a friend to tell another friend that this is actually happening. So thank you so much, and I do hope to see you on the Facebook group, and you can interact with me as well in case you do have any other questions about Erasmus programs. So thank you once again, and have a great day ahead.
Thank you, Dr. For that good presentation, and we found you well, and we are grateful that you have really enlightened us on the opportunities that exist in the Erasmus program, and we hope that we'll be able to get more on board in this umbrella of Erasmus. Thank you so much, and welcome the participants. Just in case you've got a question, one or two for Duta. You can as well write your questions and comments on the chat platform, and you'll be glad she is going to take them up. 1 minute for that. I'm not seeing some questions, but just in case, you can also raise your hand on the platform. Great, thank you. Since we do not have some questions, I will welcome Luca to give his presentation and also tell us more about the RILEM activities. Welcome, Luca.
Hey, just sharing my screen.
Just as it shares the screen, I want to say a few things that Luca Valentin is an assistant professor at the Department of Geosciences. He owns a PhD in Earth Sciences, awarded by the National University of Ireland in Galway. His experience, his expertise and research interests lie at the intersection between applied mineralogy, material science, and physical chemistry. He is an active member of RILEM technical committees on calcine clays, supplementary cementitious materials, and on carbonation of concrete with supplementary cementitious materials. He currently collaborates with several academic institutions based in African continent, that is Kenya, Ghana, Cameroon, and Tunisia, on the issue of local raw materials for sustainable construction. He is a member of the Departmental Internalization Committee and the local coordinator for Erasmus mobility flow between Meru University of Science and Technology and the University of Padua. So with those few remarks, welcome Luca, and make a presentation as well as that of RILEM.
Yeah, thanks, Joseph. Thanks for the introduction. Good morning, everyone. Good afternoon to our friends following from Asia. Welcome to this workshop, Karibu. So just to start, let me please thank our supporters, the Erasmus program of the European Union, RILEM Association, University of Padua, Department of Geoscience, Meru University of Science and Technology, and UN Habitat. I will just, in the next 10 minutes, give a short presentation of the RILEM Association. I know today there are several members of RILEM among you. Some of you may know RILEM, some may not. So as you can see, RILEM is the international union of laboratories and experts in construction materials, systems, and structures. RILEM, it is the acronym of the name in French, you can see here. And indeed, RILEM was founded in France, Paris in 1947. You can see the names of the founders here. It was quite very international since the foundation. The one in the photo is Robert Lermite. Now RILEM has a prize, as a medal dedicated to him. I will talk about this later. The main goals of RILEM are promoting international cooperation, so totally in line of with today's workshop, fostering innovative research in construction, and promoting sustainable and safe construction. As of today, RILEM has about 2,600 members. You can see the geographical distribution here. So we have members from all over the world. These are the current presidents of RILEM. So Dr. Ravindra Gettu is the president, Nicolas Roussel, vice president, Johan Vinke, outgoing president, and Pedro Castro Borges, elected honorary president in 2021. Here you can see a chart displaying RILEM organization. So it is a bottom-up organization, meaning that all decisions are taken collegially, or all decisions are voted by RILEM members once every year during the annual RILEM week. Regarding memberships, there are different kinds of memberships available. Corporate memberships for institutional members that can be academic institutions or from the industry, or also individual memberships that can be for senior members or young members under the age of 35. And RILEM indeed pays a lot of attention to young members. I know today there's a lot of master students, a lot of PhD students. So please consider becoming a RILEM members as a young member. And inside RILEM, there's also Youth Council. Today there will be one speech from Nonkululeku Radebe, which is one of the persons in charge of the Youth Council. So as a RILEM young member, you will have a chance to interact with this Youth Council. And you can see the fee for young members is actually quite low. So if you're below 35, you pay just 25 euros for the membership. This is the fee for senior members and retired members. And also, if you're coming from countries with relatively low GDP, there are discounts available. So please check all information about membership at RILEM website. I mentioned before the RILEM annual week. So this year will be held in Merida, Mexico. It happens every year, generally between the end of August and the beginning of September. Also every year there's the RILEM Spring convention, normally in March. Next year, 2022, will be held in Paris to celebrate the 75 years of foundation. RILEM also promotes several educational activities, such as sponsored doctoral courses, and also a series of webinars that are broadcast in the RILEM YouTube channel. And the core of the RILEM association is represented by technical committees. A technical committee is a group of people, of members that share the same interest, so interested in the same research topics. All RILEM members can register for any technical committee, and TCs produce a series of documents, among which state-of-the-art reports or recommendations. Currently, there are about 40 active technical committees. Again, you're invited to check all details about any of these TCs at RILEM website. RILEM produces a series of publications, among which reports, recommendation, proceedings, and also all these publications are freely available for RILEM members. And RILEM also publishes academic journals. So RILEM flagship publication is Materials and Structures. You can see here the impact factor for 2019. Actually, the latest impact factor for 2020 raised to 3.4, more or less. So there's a raising interest in this journal. So please consider Materials and Structures as a possible outlet for your papers. And also, since 2016, there's a new journal, RILEM Technical Letters, which is a fully open access journal. Also, every year, RILEM members receive, I believe, in paper, the printed, in printed form, the annual and the technical report. So I was shortly mentioning prizes, medals before. So there are two medals, Lermite Prize for researchers less than 40, Gustavo Colonnetti Medal for researchers under the year of 35, and also awards for best student posters at the annual week, and also PhD grant awards. These are the medalists of the from last year. This is my friend and professor Tung Chai Ling, Mia Hubler, and Branko Xavier. These are the RILEM honorary members elected in 2020. And just showing the logos of all RILEM corporate members, so both from the industry and the academia. We have a lot of them. And also, RILEM endorses sustainability by the Globe. Last year, RILEM launched this Globe initiative by which it aims to raising consensus and awareness towards sustainability in the built environment. Again, please check all details at globe.rilem.net, where you can also sign this appeal. And if this presentation drove some interest into RILEM, you are welcome to contact the Secretariat through these email addresses. Okay, this was all about RILEM. So in the next few slides, I will just shortly present the topics of this workshop. So the idea behind this workshop was conceived behind as a way to launch, to inaugurate our new Erasmus Plus agreement between Meru University and the University of Padua. I was very happy because this was a chance to create a collaboration between a very young and ambitious University of Meru, and historic University of Padua. Of course, we had some troubles due to the COVID situation, but very soon we will start the actual exchange program. So we will have staff and students going from Padua to Meru and vice versa. Okay, this program will run until 2023. So with this collaboration and with this workshop today, we want to address sustainable development goals related to the construction industry. I think you're all familiar with the sustainable development goals. So first goal we want to address is global partnership, which is also the name of this workshop. And I just want to pay tribute and thank Wolfram Schmidt for organizing the IC conference that was organized in Nairobi in 2019. I think this was a very seminal conference from which we drew some inspiration. It was also the conference where myself and Joseph got to know each other, and it was a very multidisciplinary, very different conference. So I think international cooperation is really very important. It is important to share knowledge if we want to address these issues. So the second topic is climate change. So we're all aware that if we want to mitigate the increase in global temperatures, we need to strongly reduce CO2 emission. And as you know, here you can see a time series of CO2, different kind of CO2 sources. So until the beginning of the last century, so coal combustion represented the main source, of course, of anthropogenic CO2 emissions. But nowadays you can see cement covers a fair share of about 10% of the anthropogenic CO2 emissions. So today, some of our speakers will introduce some innovative ways to produce low CO2 cement. Another important issue is the current fast rate of urbanization. Again, you can see this time series here. So for most of the history of humankind, most of the Earth population was concentrated in rural areas, and the crossover occurred around 2005. So since 2005, we had more than 50% of the Earth, of the world inhabitants being concentrated in urban areas. And you see this curve is increasing sharply. And predictions tell us that by 2050, 2/3 of the world population will be concentrated in urban areas. This exerts a strong pressure on cities. This can lead to a situation of spatial injustice, of housing backlog. Here I reported some numbers from sub-Saharan countries. There are some really dramatic situations. You can see for the Central African Republic, like about 25% of the population does not have access to decent housing. So we really want to address these issues, also knowing that most of the cost associated with the housing in the African scenario is associated to construction materials. CO2 emissions is not the only impact related to the construction industry. You can see here this chart showing material flows. It tells us that every year nearly 100 billion tons of resources are extracted from the earth, and more than 40% of these raw resources feed into the construction industry, and less than 10% of these resources are upcycled. So we really need to make the construction industry more circular. We'll have also speakers today talking about this. And also another impact related to construction industry and to quarrying for the construction industry is landform modification. So it affects the landscape, which in turn affects the society. So if, I don't know if any of you is familiar with this Anthropocene project, and I strongly recommend to check the Anthropocene documentary, a very powerful documentary available online. What is it about? Well, according to geologists, we have now entered a new geological epoch, the human epoch, in which the impact of human activities on landscape is now comparable to that of geological forces. So also today we will have a nice presentation about this topic. So just to end, I think the response to this workshop went, Joseph, beyond our expectation. We had more than 250 participants from 44 countries. I apologize if some of the countries are not displayed because we had a new registration until the very last minutes. So I didn't have time to update the map. So, okay, I think it's time for myself to shut myself up. Just a recommendation for our speakers during the question and answer session. I recommend to give priority to the attendees to ask a question. This can be done through the QA button that you find at the bottom ribbon of the Zoom platform. Okay, so welcome once again, and Joseph, I leave it up to you to introduce the next speaker.
Thank you so much, Luca, for that good presentation on RILEM and also your presentation as well.
Sorry, Joseph, I saw there was a question about RILEM. Somebody's asking if membership is annually or a lifetime. It has to be renewed each year. But as you see, for a young member, the fee is very low, and also there are reduced fees for membership from low GDP countries. Okay.
Thank you, Luca, for the answering the question and for the good presentation. I wish to now invite the next speaker is Ganda Vasinoi. He's a professor and the head of chemistry division at the Faculty of Engineering, Ain Shams University, Cairo, Egypt. She is an elected member of the Executive Bureau of International Union of Pure and Applied Chemistry, and a member of the Egyptian National Committee of Pure and Applied Chemistry. Pure and Applied Chemistry, Egyptian Academy of Scientific Research and Technology. She was appointed as the Egypt-German and Egypt, Italy, and Egypt, Japan coordinator, Science and Technology Development Fund, Egypt Ministry of Higher Education and Scientific Research from the year 2013 to 2021, and has been a member of the Global Youth Academy from 2013 to 2018. She has been recognized with several national, regional, and international awards. She is a Fulbright. Next Instinct Forum, African Science Leadership Program, and a fellow since 2016. She has organized significant number of scientific and gender-related workshops and conferences, and co-led the Women in Science Working Group of the Global Youth Academy for several years. And that is our presenter today. Gada, please, you have the opportunity and to make your presentation. Thank you so much and welcome. I also am glad that we are able to meet in several forums previously. Thank you. Welcome.
Thank you very much, Joseph, for this very long introduction. Thank you so much. I'm very humbled to listen to all this. Thank you. And thank you for your kind invitation. I would like to share my screen if you'd allow. So in order to start with my presentation. I hope that you can see it. Okay. So I would like to talk about the international and inter-African cooperation, challenges and opportunities. Just like Luca was just mentioning, we have very nice fora that we meet, but it's only out of pure luck that we meet in these fora. How can we tackle these challenges that we don't know each other, and how do we see the opportunity in meeting with each other? So this is what I would like to talk about today. Thank you. Yes, my name is Reda Bessiuni, and I'm a professor and the head of the chemistry division at the Faculty of Engineering at Ain Shams University. I'm a chemist by profession, but work at the Faculty of Engineering, so I'm doing applied chemistry work. The Faculty of Engineering has been established in 1839, so it's a 180 years old institution, and I'm privileged, of course, to come from Egypt with the ancient history. So let's talk about the challenges that we face in Africa as defined by the United Nations. The United Nations has defined three main topics that are a big challenge in the African continent. The first is education and skills development. The second is building sustainable governance systems. And the third one is delivering hard infrastructure. So, you know, as long as we define the problem, the challenge we have, we are able to mitigate and control it with means, with research means and good ways. So, can we just rely on what the United Nations is telling us about the challenges we face? This can be applied to any continent, actually. But when we look at the African continent with the huge capacity of human resources and material resources, what are the challenges on a local basis? For example, for research for young scientists, for example. So we wanted to look at this in a more specific way, and the Global Young Academy, which I was a member and now I'm alumna of, has created like a report doing some statistics on the global state of young scientists in Africa. And this can be fully seen as a PDF file. It's about the voice of early career researchers in and out of the academy, a pan-African perspective. And I think this kind of report is unique because you listen to the young voices and see what they have to tell us about the challenges they face. And I would like to share here a quick overview about this report in form of a video. And I hope that you can hear. Can you hear the sound?
Own kind of personal background.
If the sound is
reagents.
Yes, we hear the sound.
Okay, good. So I'd like to start with her.
There's been a lot of sensitization to do a lot of collaborative research, interdisciplinary research, like north-south, south-south collaboration, but you have still not been able to have, that high research output coming from Africa. And we want to understand really what are the challenges, how can we address these issues, and how can we fill in that gap among young scientists in Africa. Some of the issues actually that I would want to voice beforehand is issues of mentorship, training gaps, support systems for particularly women scientists, funding, and many other issues that may hinder research output in Africa.
The first step that we do once we have all the data is analyze it, compile it, and create a report that we then spread to different stakeholders. But another kind of more long-ranging purpose of this data is that we plan to create a database of comparable data across regions. And this is something that doesn't really exist right now. So there are studies of scientists in these different regions, but there aren't comparable data. So we don't ask scientists the same question across region. So this is something that's really innovative and new and with a lot of potential. Because, you have this movement, this globalization movement, right? So you have this sense that there's this wide global scientific community, but we have to understand where these scientists are coming from and the kind of obstacles they face and how that might impact where they stand in this global community of scientists.
What we expect from this study is that we will have evidence-based research, we'll have empirical findings that we can use to influence policy, to advise governments, because when you have something tangible, it is easy to convince stakeholders and decision makers. And with that, we can also come up with intervention measures, intervention strategies, because we know what the problem is, and therefore we can come up with approaches and programs that can address those specific problems that the young scientists face in Africa. Because young scientists are the future of the world, and Africa has a very large population. So if we can tap on this young, positive energy, I believe we can change the continent. Positive has a very large population. So if we can tap on this.
Okay, so I'd like to go to the next slide, but I don't know how to.
Gada, I think you have to click again on share screen, and this was embedded in the presentation.
Yeah, it's embedded in the presentation. So
you should just press the
yes, thank you. I managed. Thank you very much. So I will show you now the output of this report. The output was very interesting. When they asked the young scientists about the impact of challenges on their careers, the most important factor was the lack of funding opportunities. And then the lack, more than 45% of people were responding that the lack of funding is the main factor that is impacting their careers in Africa. Then comes the lack of resources, staff, materials, and then the lack of support, identifying and applying for funding, and then the lack of training opportunities. And as we just heard in the report, that it's also the mentorship thing, and that people need to be guided throughout their career. What is amazing here, which is really different from other continents, because we did the study on a global basis and then on a continent basis, that you can see that the impact was least about the periods of unemployment, that the periods of unemployment or the work-family life balance is not an issue in the African continent, which is really amazing, and we need to understand how this is possible. I believe that it's because of the tribal nature of the African continent, as well as the family connections and the relationships that enable people, and especially women, to go through their careers on the African continent. So this study is very interesting. The full study is available. It's an open access to everyone. So if you would like to understand more about the status of young scientists in Africa, so I would like to invite you to read that report. So how can we make use of the networks, or the how can we overcome these challenges that face us? When we talk about lack of infrastructure or lack of resources, I believe that the first and utmost important issue to tackle this is collaboration. But how can you collaborate with people you don't know? So you need to go into platforms that allow networking on an international, but also on a Pan-African basis. So I just showed you something that the Global Young Academy created. I will just show you briefly within this presentation what is the Global Young Academy about. The Global Young Academy is global, as it says in its name, but we also have some national young academies that is also fora, that in local fora that let people with same mindsets meet up in a very natural and young way. So these three things, the Global Young Academy, the National Young Academy, and the next Einstein Forum, are the three platforms that I know very well about, that allow people to interact and mingle like myself with the same mindset within academic background, and to people who really face the same challenges, although they come from different countries, they can meet up and help each other. And I can tell you, I'm an next Einstein Forum Fellow, like said in the introduction, and the next Einstein Forum, I realized for the first time in 2016 that we have such a great potential of young scientists in Africa, but we need to know each other in order to, work side by side and help each other. We also have other fora on a larger scale. Also senior people are involved, like in the African Academy of Sciences. You have all types of ages involved, also with the same mindset, which is really academicians and so on. And then we have also organizations that support and enhance the performance of women in science in the developing world, like these organizations I mentioned. And the Global Young Academy actually has always like 200 members, and we have the terms of membership is for 5 years, and you have like the biggest or the oldest age is 45, so that's why we call it Young Academy. Like myself, when I become 47, I'm now old, so that's why I'm an alumna of the Global Young Academy. So in the Global Young Academy, you only find people who are under the age of 45, and the membership is really great because later on you have a long-term relationship with all these people. And nowadays, the Global Young Academy is opening up a new call for new members. The selection criteria are very tough, but then in the end, when you get in, you will really benefit from everything they are involved at, and they can help you, develop your soft skills and develop the collaboration level. The National Young Academies are also founded 20 years ago, and you can see here that some in the African continent, you have many who have started like really 20 years ago, but then because of their success and that they are becoming the voice of young scientists in these countries, the other countries have adopted this kind of scheme. And even in Egypt, the Senior Academy, the Academy of Scientific Research and Technology, has also adapted the Egyptian Young Academy 10 years ago. And I really hope to see more of these academies in the continent so that we can interact on an institutional level together. As I mentioned, the next Einstein Forum is a forum that awards young scientists for their achievements. And you can see here that out of 15, there have been six women scientists awarded, with the president of Senegal and the president of Rwanda giving us these token of appreciation. Because in the next Einstein Forum, we believe that the next Einstein will be an African. So I would like to invite you, if you believe in our continent and the potential of this continent, please become a part of this and get involved. But what are the opportunities for funding, or what can the funding include? So the funding, what the academicians seek at are, for example, educational or just scientific research, or of course awards. Vocational training is also very important, soft skills development, and special programs for women. So these are the funding opportunities, and you can search by these keywords for funding opportunities. And one of the most important platforms for leadership and management training have been provided by a program that is called PAUSE, that is a program advocating women scientists in STEM education that was sponsored by the Bundesministerium für Bildung und Forschung in Germany. So this is the Ministry of Research and Education in Germany. They have created a platform that can build up the leadership skills for women in Africa, funded by German money. We have also the Canadian Institute for Advanced Research has done a lot of workshops to enhance leadership skills for women in Africa. But I would like to point out that we have one big and the first African program that is really tackling leadership and management training is the Africa Science Leadership Program. And please allow me to introduce a little bit about the African Science Leadership Program, because it's a program that it's a new initiative of the University of Pretoria in South Africa and the Global Young Academy. As I just mentioned, the Global Young Academy with this diversity can create a lot of innovative ideas, and this is one of these ideas. With the support of the Robert Bosch Stiftung, so money is also needed to create new ideas. Robert Bosch Stiftung is, of course, a German industry. It aims to grow mid-career African academics in the area of leadership, team management, and research development, with the intention of enabling them to contribute to the development of a new paradigm for science in Africa, focused on its contribution to solving the complex issues facing both Africa and the global community. And I would like to show you a little bit about the program by watching this video.
I think I've always felt that there is a gap, even in my own professional development. I felt that there was a gap with respect to issues to do with science leadership. I have taken up some courses, business leadership in some other courses, but there's something which is missing from it.
I had more questions than expectations because I didn't have so much experience in Africa or working with Africans, even though I am an African, but unfortunately we don't have so many such opportunities.
There is the need to build collaboration among young researchers in Africa. From this workshop, I've been able to also connect with some other young scientists in other parts of Africa.
It is a network of young African science leaders. It prepares the next generation of science leaders.
What stood out for me is the projects that have emerged within us. The themes that we managed to come up with, it showed that we are really connected.
leadership, and especially leadership in science, doesn't start in the specific research field you are actually working in. It goes on so many different multi-layer overlapping levels.
When it comes to science leadership, there's a difference between being a leader in the academic environment and also being a manager outside the academic environment.
I found the week very intense in a good way.
Talked with many people, and it was completely different from any other thing we have attended before.
This has been the best workshop so far I've ever attended in my career.
The program, the people, the activities, the goals. I don't think we even should call it a workshop or conference, because it's so much innovative to be called in such a very traditional way.
So I gave you now an overview about the Africa Science Leadership Program, and I really benefited a lot from this program. It taught me how to look and to be more tolerant and to look to other perspectives and embrace other people's opinions. And you know, when we meet up with other Africans as well, we have so many things in common, but we don't realize unless we meet. So what are the agencies that fund research in Africa? We have many international research funding agencies like the UK Department for International Development, or the WHO, or the World Bank, USAID, or New Zealand Aid, and the Australian Aid. All these are international. Some, of course, I didn't mention all of them. But we also have industry like the Robert Bosch Foundation or the Volkswagen Stiftung. But also we have two main entities that fund African scientific research by Africans. We have the Science and Technology Development Fund in Egypt, which has been created almost 20 years ago, and the National Research Foundation, the NRF, in South Africa. So these are the two big entities in Africa that can fund African research. But let me show you something about the Science and Technology Development Fund. We had two calls so far. The one in 2013 that was called Air Africa on renewable energies and interfacing challenges. It was the first call. And can you imagine, we extended the deadline for 2 whole years. This usually doesn't happen. Usually when you have any funding agency, you would find the announcement and then like 2 months, maybe 3 months to the deadline. But you can see here that we gave the African scientists a chance for a whole 2 years to apply for such funding. And this tells you a lot about that we did not have the anticipated number of projects or proposals that we wanted. And we were just postponing the deadline until we had a number of projects coming in. And also the South Africa, which is the NRF here resembled as the NRF, and the NDASH, Egypt Joint Science and Technology Research Collaboration. This also was announced in 2013, and the deadline was even extended for 3 years until 2016. And so I really hope to see more of these collaborations, but there has to be a need for it, you know. When we African scientists among each other would like to collaborate, and we tell our funding agencies in the African continent that we need such kind of funding agency, then they would listen to us. But when they have a call and we don't get enough proposals, this tells them that there is no need, unfortunately. So I would really like to call out for a more Pan-African collaboration. The National Research Foundation, also in South Africa, is tackling up-to-date topics like the corona topic. Also, the Science and Technology Development Fund did that as well. But let us ask ourselves, why is the pandemic not handled by any African? Why didn't Africa produce any of these vaccines or any medication that can tackle up-to-date diseases, you know? So this gives us or leaves us the question that, is it actually a lack of knowledge? No, I think it's just the lack of collaboration. So we need to collaborate more in order to benefit from each other's knowledge. 2 years ago, the first African South cooperation report has appeared. And imagine just 2 years ago, from a continent that is an ancient continent. This is kind of a pity to realize that we just in the last 2 years, we started to go into South-South collaboration. And this has been funded even from outside. It's not something that has been created in Africa. So I really wish to see more of this, and maybe this kind of fora. And I would like to again thank Joseph and Luca for hosting such events so that we can understand the lack and try to overcome it. A very nice forum to publish even of course, scientific results that are case study based on local basis, as well as on a global basis, is the conversation that can really simplify things. And you are always, if you have a nice topic to talk about, you can just write to the editor. They are always very welcoming contribution from African scientists. So this is, for example, one of my contributions, with a very nice team coming out from the Africa Science Leadership Program. We talked about how Africa can empower more women to become leaders in science. And we chose the conversation as a forum for our publication, and it was well received and has been read by more than 1 million readers. And we have also here in Africa, the Research Africa. This gives us news about the African continent, what is going on, what are the challenges, because, you know, we tend to read and listen to media that is more of a global nature rather than a regional or continental basis. And also for scientific research, the Scientific African is a very nice new journal that has been created by the Next Einstein Forum Fellows to also address topics related to research in Africa. And of course, you're also invited to publish your results in the Scientific African that is published by Elsevier. So it's a Scopus Index journal. And with this, I would like to leave you and thank you very much for your kind attention.
Thank you very much, Ganda. It is always a pleasure listening to your presentation and quite inspiring. And I'm glad to have also heard more about your programs as well, both for the Africa and I mean Egypt and German and so forth. And we hope that this will make us move forward also in future. Thank you so much. I think there are a couple of questions on the chat, but I would request that maybe Ganda would respond to them on the chat so that we have sufficient time for our next speaker. Is that okay, Ganda?
Sure, sure.
Thank you so much. And we hope she will be responding to them. I see one from Dekelendi and Emraj, and they will be responded to in the chat. Thank you so much. At this point in time, I want to welcome the next speaker, and that is Mike Otieno. And as it comes to stage.
Joseph?
Yeah, Luca. Yes, I can hear you.
Yes,
I don't think so. I think
I think we've got Alicia now.
Oh, okay. Sorry.
Yes. Hello.
I think I've seen Alicia. Yeah.
Yes, can you hear me? Okay, so I'm going to
good. Yes, well, thank you. Alicia is a sustainable housing expert, part of the UN Habitat Land Housing and Shelter Section, Global Solutions Division. Alicia assesses sustainable and future-proof building and construction within the environmental, cultural, and financial paradigm of the 2020 agenda. An international architect with a multidisciplinary background in architecture and urbanism. She has developed a career across Europe, Brazil, China, and Australia with a human-centered and participatory approach to buildings and construction. Alicia has been part of public and private sector training, private sector aiming to strengthen the sustainable building and construction strategies from the environmental, social, and financial perspective, and searching for innovative and pragmatic solutions that are human-centered and environmentally conscious. Alicia balances her professional career with her research with buildings and the construction department at ESM, Technical University of Madrid. So welcome, Alicia, for your presentation. Thank you.
Thank you, Joseph, and thank you, Luca, for the invitation and for this nice workshop where we've seen a lot of professionals from different backgrounds sharing their expertise, and especially mainly related to SDG 12 and also resource efficiency. That's what I've come to talk about. Would you let me know if you can see my screen right now?
Yep, we're okay, Alicia, thanks.
Yeah, okay,
yes.
Thank you. Welcome.
Thank you. So as I was saying, I come to introduce to a program that we are developing within UN Habitat currently. But as Joseph was saying, I'm part of the Global Solutions Division, which means that we work cross-nationally across countries to strengthen SDG 11 and SDG 12 in my case. Is not only sustainable housing and access to adequate housing to all, but as well related to material construction, sustainable buildings and construction. And in this specific program, you will see as well how we respond to climate change in the sustainable buildings and construction sector. I wanted to highlight that we are part of the Global Solution Division because this program has been funded by the Multipurpose Trust Fund of the One Planet Network and is part of the 10-year framework of programs. And it's been implemented together not only by UN Habitat, but UNEP and UNOPS are supporting several parts and activities of the program. So, without more delay, I wanted to show you a bit the challenge. So as we are seeing, and as introduction has also highlighted, the building and construction sector is responsible for nearly 40% of the global greenhouse emissions. And the program responds to the urgent need to reduce those emissions, and it does a main focus and a particular focus on material development, raw materials extraction, material transformation, transport to the sites, and as well construction and deconstruction. So an approach and a holistic approach to the building life cycle as well. Within this, we know one of the quotations is that 50% of the building stock is yet to be built if we talk globally. And most of it will occur in developing countries, mostly identified in Africa and as well, Southeast Asia and South America as well. What does this mean? It means that although we are seeing a global framework and a strategy to reinforce the reduction of carbon emissions, we're going to see a different approach if we look geographically to different areas. For example, if we're talking about Europe, the focus is on refurbishment and as well in the transformation of the current building stock, because the statistics show that, For Europe, for example, for 2050, 70% of the building stock has already been built, which is something very different from what we see in other regions that are the ones that we are targeting with this program. So we're going to be talking about new construction here mainly, and with a focus on housing. And why housing? Because among the total building stock of a country, housing, when we talk about buildings, not only infrastructure, is referred to from 70 to 90%. So by this, we can tackle not only the majority of the population and a basic need, that is housing, but also we can aim to improve the whole sustainable framework of buildings and construction, meaning not only green housing or resource efficient, but as well tackling affordable housing and socially and culturally adequate housing. So this is the challenge that we are facing. And this is one of the projects or programs that the UN has established together, as we are saying, UN Habitat, UNOPS and UNEP. And it's called SDG 12, in order to tackle that SDG 12, sustainable consumption and production, resource efficient housing. And the main objective is to equip governments and, well, through the UN country teams and other stakeholders, to equip the governments with the necessary tools and information to increase and transform the sustainable buildings and construction sector to become more resource efficient, low carbon and climate resilient. This is one of the first main objectives and targets. The second one would be to raise awareness and to strengthen the capacity of national stakeholders. So I'm going to introduce you a bit in the next slides about the stakeholders group that is being built in each of the countries we are piloting, or the countries that we are developing this program together with, because it's also a collaborative program with the countries, the country offices, and as well the national stakeholders. And the third one is, as I was saying, to strengthen productive links, the construction sector of stakeholders, and to be able to identify the gaps within the construction value chain to improve the resource efficiency and a more circular economy. If we link, as Luca was introducing in the beginning of the workshop, the link to the program with the SDGs is critical and crucial, and especially not only the link but the localization of this SDGs within the countries that we are working with. So the program obviously targets SDG 12, and we can see the activities of SDG 12.2 and 12.5, but also we are targeting 11 and 11.1 and 11.c when we are talking about sustainable housing and construction materials impacting the house. And if we go a bit further, I'm going to introduce you some of the main highlights of the what we have already been working on, because it's a 2-year frame program that started last year in around December. So we've been going through maybe 25% of the process. And the first, the first framework that we wanted to highlight is the importance of the value chain. Here you can see a chart of, a figure of the report catalyzing science-based policy action on sustainable consumption and production by the One Planet Network, where we can see the supply chain starting with raw material, manufacturing and distribution. But that's not only what's being impacted. If we analyze the value chain and we impact the different stages of the material consumption and production, we will introduce as well the perspective of consumers. We will upskill or upcycle the waste and the importance of starting to think of recycling in construction materials as well. And not only that, but the impact of the whole value chain with economical access. So for example, a lot of time we see the need to improve sustainability or resources and the materials we use for construction, but we have to keep in mind that that cannot impact the affordability of the houses, or it cannot impact too much the access to adequate housing. If not, it won't be a sustainable solution for most of the population as well. So this is something that we have been seeing, and if we decompress the whole value chain and we start thinking by the different phases where we see from the financing stage, the planning, design and commissioning stage, the construction material stage, logistics, construction, and property market. So this would be all of the stakeholders and all of the parties that would take place during the construction life cycle of a building. And we have identified, well, the One Planet Network together with us has identified the phases in which resources have the most impact, and well, the resources are used and have the higher environmental impact. And as I have quoted here on the left from the same report, there is little, and well, not little, but there is less analysis and knowledge up to date that combines overarching the extraction process and the many different materials used along the construction value chain. This, which means that there's a higher focus as well in energy efficiency over material use in the construction sustainability process. But with this programming, and particularly in the countries that we are going to implement it, we saw that the need, or how they see the process, they see the sustainable buildings and construction roadmap for the country in the next 30 years, that has a very large impact. Or the strength, what they want to strengthen is the materials that they use for the construction, and also the sourcing sense of those materials, or the importing of those when we see the cases, because that's one of the challenges they have to strengthen the construction sector. And if we gather the different activities that will be covered by the program, we started with an inception report that has already been finished. But currently what we're doing is developing the country-focused activities, and the 2 countries that were selected among a lot of submissions that we received were Sri Lanka and Burkina Faso. And we are working together with them in the phase, well, that I called here number 2. And it comprised 3 main activities, which the first one, the overall outcome is to be a sustainable buildings and construction country roadmap. And for that, we're building on a stakeholder mapping, country assessment, and sustainable buildings and construction roadmap together with UNEP. And an advocacy package, so that it's a global collection of the current existing assessments, certifications, and tool. And then after the global analysis, selection of the main tools that would be relevant for these countries in the state they are, and with the objectives that they have, to be able to assess their buildings and construction sector. And third but not least is the strengthening of a value assessment methodology for sustainable housing, and a draft certification that lies on top of a tool that we are already using, and that is free of access from UN Habitat, that you can search online and access. That is the Sherpa tool, that it's a self-assessment tool for sustainable housing projects. And the last and the third activity would be the piloting of these tools, and mainly the Sherpa, into national housing construction programs. So if we regarded the 2 countries that were included, or that we are developing this program with, Burkina Faso and Sri Lanka, I just wanted to highlight some of the reasons that we made us engage these countries for this specific project. The first one was, as we were saying, the need to strengthen the material value chain, and the particular issues that they have in sourcing materials for construction. In the case of the Sri Lanka, one of the challenges that they have is that the level of imports is very high, due to the condition of being an island, one of them, and as well is becoming more critical due to, for example, the sand crisis that they have in. They are sourcing sand from the riverbanks, and now they're trying to upgrade it as well to sea sand, but it's not having all of the acceptance in the population, and it's having growing problems within the construction sector. Regarding Burkina Faso is undergoing a critical time due to migration. There's above 1 million interior migrants in the country, and with the correspondent housing crisis, also strengthened by the COVID-19 crisis. And the government as well wants to upgrade the housing solutions that been delivered for shelter, and not only shelter, but to strengthen the life of those buildings that is being constructed and improve the materials being used. Burkina and Sri Lanka, both countries have a long history of innovation and technical innovation in the countries regarding sustainable business and construction. For example, Sri Lanka has a very advanced green rating system for new materials and materials in the country. And Burkina Faso has some of the construction technology development laboratories that we aim to engage with, and that have been developing several very interesting buildings in the country as well. I think I have very little time left, so I'm going to rush through a visual on the examples that I was going to show you. Regarding Sri Lanka and Burkina Faso, they have been mapping their value chain assessment and integrating and locating, identifying and engaging the stakeholders. So the main stakeholders to be part of this whole network within the country. Stakeholders come from the government institutions, from the private sector, for other public institutions, NGOs, and as well private sector and real estate sector companies. As you saw, this is a overall primary mapping by Sri Lanka, where they also selected and did a whole scoring to select the main stakeholders. Currently, there's among 30 in the final list. And Burkina Faso as well, we can see here the mind map of the main stakeholders that they identified to be main, critical to be able to shape and strengthen the whole value chain. From these stakeholders, as I was mentioning, we are starting a country assessment, and the overall objective is to develop a roadmap for sustainable buildings and construction for the country from now to 2050. And the last but not least, that I think maybe you can see it online as well if you want to have further look at it, or always consult me through email. There is the value assessment tool. The Sherpa that I'm pretty sure some of the members here already know is a self-evaluation tool for project managers, communities, and architects, and not only architects, but the whole sector, in order to do a self-assessment and analyze our buildings and construction. I'm going to skip through here, and maybe while you see the short video, can just continue explaining. So this is the overall tool, and when you enter, it enables you to rate your design or your building in a qualitative, so not quantitative manner, through four, it's a holistic assessment through 4 levels that are territories, processes, neighborhood, and household. So through very simple questions that all of us mostly can answer, gives us an overview of the project that we are developing. I like to say that it's an active tool, so not passive, which means while you respond to the questions, as you hear here, it gives you a visual feedback on the status of your project, and it also gives you ideas on how to improve if you read the other answers, or what is expected in order to improve your construction or your design. And yes, the idea as well with this program is to upgrade the Sherpa and strengthen the pillar on resources, materials, and the building life cycle as well. And always continue to be, at least for the moment, always to be continue to be an open source and free to access for all countries. And it's a tool that's been specifically developed for the global south and all developing countries, meaning that it's not focused only in energy consumption, but on the whole value chain, and grading the projects within 4 pillars of sustainability, as I was mentioning in the beginning, and you can see here, environmental, social, cultural, and financial as well. I hope I didn't rush too much throughout the presentation. And if you have any questions, please let me know through chat or email. Thank you.
Thank you so much, Alicia, for the good presentation. Indeed, it's quite insightful. I will still refer to anyone who has some questions still to use the Q&A platform, and I know that Alicia would be glad to answer them in the same platform as well. At this point, I would wish to invite Kolawale. Kola, if you can hear me. Yes, I can see Kola. Kolawale Adisa was awarded a PhD degree. You can hear me, Kola?
Yes, I am hearing you, Joseph.
Thank you so much, and welcome. Good to see you.
Are you too?
Yeah, I was saying that for the purpose of the audience, Kolawale Adisa was awarded a PhD degree in civil engineering, civil and environmental engineering from the University of Lagos. His area of specialization is structural and material engineering. He is a cement and concrete expert. He pioneered the use of cassava peel ash as a replacement for cement in concrete, which granted him the German Africa Innovation Incentive Award in 2019 by the German government. He has been a guest scientist at BAM, Berlin, and the University of Sao Paulo in Brazil. He is a fellow of the Nigerian Society of Engineers and an initiator of Society for Cement and Concrete Researchers in Nigeria. He is an active member of RILEM and has participated in 3 technical committees. Presently, he is a senior lecturer in the Department of Civil and Environmental Engineering, University of Lagos in Nigeria. Welcome, Akola, as you make your presentation on the potential of bio-waste as a replacement for concrete, for cement in Africa. Welcome.
So thank you so much, Joseph, for the introduction. I want to believe, can you see my screen?
Yes, you can see it.
Yes, thank you so much. I really appreciate Joseph and Luca for the invitation to attend this all-important program. Yes, I will be talking to this important audience on potential of bio-waste as replacement for cement in Africa. Yes, like I've been introduced, Kolawale Olonode from the Department of Civil and Environmental Engineering of University of Lagos. Our university is one of the first generation university in Nigeria. It was established not too old, but around there it was the second university to be established in Nigeria after University of Ibadan, and is considered to be the nation's pride and the university of first choice. Yes, I'm always fascinated with this figure. If you look at Africa as a continent, Africa as a continent in terms of land mass has the potential to subsume the whole of Europe, US, China, India, Argentina, and New Zealand, indicating that Africa is extremely big continent in terms of the land mass. In terms of the population, Africa is next to Asia in population. And when we look at the number of the area where we need substantial development, we need more of this also in Africa. Why is it that Africa is well blessed, and what are those things that is really attracting a lot of attention to Africa? Africa is blessed with abundant natural resources. If you talk of solar power, if you talk of in terms of fossil fuels, in terms of other grain materials. In terms of population, the population, Africa has the largest young population in the world, even not even in the compared to Asia. and the population, the rate at which it is increasing is increasing at the fastest rate. Yes, there is a relative peace now in Africa, unlike before. We have a relative stable government. We have the mass awareness because the democracy as a system of government is really gaining ground in Africa. Then also in terms of the economy in Africa is growing at an alarming rate, at a rate of about 5% because of a lot of diversification in the economy, and then the economy is also open to whoever is interested in investing in Africa. These are some of the things that makes Africa to be an important continent in the world. I hope you are hearing me. Are you hearing me?
Yes, we can hear you, Kala.
Okay, thank you.
Thank you.
Yes, like I did mention, infrastructure is key to African growth. And you will see that the Sustainable Development Goals, SDGs, key about 70% of this program requires infrastructure. And apart from the worldwide development goals, the Africa as a continent is also developing. They also develop the agenda, which is expected to be achieved by the member countries in 2063. And each of the country, even African Development Bank, also has its own 5-point agenda, which is also expected to be developed. Each of these agenda required infrastructure. Apart from this, there are gross infrastructure deficit in Africa. If you look according to the UN Habitat, Africa is urbanizing at a rate of 4% per year. But the rate at which the infrastructure is being developed is far, far below the rate at which Africa is being urbanized. For instance, now, about 1/4 of the roads in Africa is paved. And this is a big challenge in terms of economic development. Africa is yes, we have a lot of slums. We have a lot of slums that required regeneration. And then the rate, presently we have about 4 million housing units that is needed to be built per year for the next 2 decades in order to bridge the required housing deficit that we are having in the whole of Africa. And then in terms of power, because power is also central to the development. The power is far short. We have a short supply compared to what we have in some other developed countries. All of this is indicating that Africa requires a lot of infrastructure for its development. However, Africa is not really resting, and is rebounding and responding. And the government, everybody in Africa, especially the government in Africa, they are African countries. They are making every effort to see that how do they really bridge this gap. They are already having a lot of international cooperation with developmental organization or funding bodies to see how the infrastructure in Africa can be revamped. Yes, apart from what each of these, apart from a global goal that every continent really interested in achieving, each country also has its own developmental goal. And an assessment of each of these countries that is having developmental goal found that the infrastructure is still very key, and then followed by the capacity building. Definitely without infrastructure, without capacity building, there is nothing like trade. That is why each of these countries, they are really paying more attention into infrastructure, because that is where the economic can be grown. But for all of this infrastructure that we are saying, everything is hinged on the amount of concrete that is required. Concrete is required for very good habitation. Concrete is required to really maintain, to really take care of the rate at which the cities are being urbanized. For the ecosystem, concrete is also contributing, whether negatively or positively. So if you must have any impact, any meaningful impact in all of this, then our attention must also be on concrete. Our attitude to consumption of concrete and the type of concrete we produce will definitely have impact on what type of ecosystem do we expect to have, then what sustainability that is expected to be achieved, and then also the habitation too. Now, this figure is also an indication that because the concrete is very important and cement is a major ingredient of concrete, and cement is only the artificial material that we use in concrete, apart from some other admixtures that is added to improve the concrete, to improve the qualities of concrete. If you look at this figure, you will see that by the year 2050, the amount of cement that will be consumed in Africa is increasing because of the required infrastructure that is necessary to be developed compared to the developed countries where it is almost stagnant. And then even in China, everybody is coming down a bit because they will have reached the peak. They will have reached the optimum of their infrastructural development, where Africa is already growing. So this is why the major player of cement production in Africa, Aji Dangote, is saying that Africa's future growth is intrinsically linked to cement because we need infrastructure, and infrastructure requires concrete, and without cement, I wouldn't know if you can really have a concrete. So this is the reasons why we're having a lot of investment in cement these days. Compared to all other African countries, even in the North America and even in the Europe, there are no new investment in terms of cement production compared to what we are having in Africa. This is just about 2011 data, and what we are having now is even far above what this record is really showing. And this is just an overview of the cement industry, the players, the cement industry that is we're having in Africa. Now we look at the Dangote cement. Dangote cement is almost in about more than 14 countries in Africa. And then the same Lafarge, PPC, Edinburgh, Afisa, and several other companies, because cement is required for development. This is also a shame of how cement is being moved. There are some countries that are still importing cement either from Europe, from Asia, at times either the finished product or they import a clinker. Even within Africa, cement is being transported here and here. And all of these movements also have impact in our environment. So what we are indirectly saying is that for any meaningful thing to be achieved in terms of mitigation of climate change, there is need to look into Africa, how do we consume cement? Because cement is a major emitter of CO2 into the atmosphere. Even apart from a lot of investment that we are having cement in Africa, is the cost of per ton, the cost of a ton of cement in Africa is far higher than what we have in several other parts of the world. Like the minimum we can ever have in Africa is about $7, and while we have in Europe about 3.75, in Asia about 3.52. But why is the cost of cement is as high as this? And because when the cost of cement is high, then what that is also indicating is that there will be high cost of construction. When the high cost of construction is high, then there will be a limitation of the people who will be able to really build and get a good house for themselves. And such reasons could also be high cost of energy, high cost of haulage, because of the infrastructures are not really available to really move cement from one place to another. Then also importation of most of the parts that are required in the cement industry requires importation because they are not produced in-house. So this is an implication. If we continue to consume this, we are going to have, because we're having about 2.1 billion tons of concrete, that cement that is being consumed per year. And if we must do anything to mitigate climate effect, we must look at this cement. So we now look at infrastructure versus environment. If you want to look at the rate at which we want to provide infrastructure, we must also need to look at what is the repercussion. What is the repercussion on the environment? Yes, population is increasing, urbanization is moving at the fastest rate, we need transportation. All of these infrastructures, they're having one effect or the other on our environment. Like for instance, one sixth of the world's fresh water is being withdrawn for use in construction. And we have a lot of deforestation, ecosystem is being damaged, we have the climate change, the air there is no quality air. So is there alternatives to cement? If cement is having challenges, if you continue to consume cement, then we always have a damage to the environment. Yes, there is no alternative. For now, there is no commercially available material that can be compared to cement. But there is still other things that we could do. We could have better cement. You could have programs that will reduce the environmental effect that we have from cement. And that is why Grant Nessa says that we cannot afford to keep producing cement with conventional technologies. They generate large quantities of carbon dioxide emissions when we have the option of using more technological advanced composite cement that offer additional advantages. People have been developing new techniques, they have been developing new fuels. But from our own area, we are looking at how do we reduce the consumption of the cement clinker. And there are different approaches that people have been utilizing. In Africa, or even in the world, in the world at large, there are several other materials that have been used to either to be partially replacement for cement. That is the supplementary cementitious material. We have rice husk ash, we have cassava peel ash, we have corn cob ash, and others like that. Also in aggregate, because in aggregate, you use sand, you use granite, which also have effect on the ecosystem by the time you are quarrying most of this material. So there are several other biomaterials that have been researched in, and they have utilized. These are really giving a very good result. Even also in reinforcing concrete, we have coconut fiber, we have bamboo trunk, and several other biomaterials. And also in the admixture, in either improving the flowability or fillability of the concrete. These are some of the materials that are of bio origin. They have agricultural based material, which can be ensure circularity in terms of a circular construction. These are some of the things we have been able to compare. We know what is really happening in the developed country. We know they are already using fly ash. They have a silica film and several other industrial byproducts that are being incorporated into concrete by reducing consumption of cement. But most of these materials assembled are not available in Africa. Africa, by their nature, at least, is agrarian. They produce a lot of agricultural byproducts. And in doing that, a lot of waste are being generated. So we could also look at how do we utilize this waste so that the solid waste can be used, can be recycled in replacing cement. And we found that the quality in terms of the chemical composition of most of these ashes, they are not far from what we have in fly ash and silica film. If you have silica content, silica is silica, whether it is in fly ash or it is in silica film, or it is in rice husk ash or sugarcane straw ash. Whatever we do is a pozzolanic reaction that always takes place, that will also take place in most of these agricultural byproducts. That is why in Africa, we need to look inward. How do we develop most of these bio-based materials, at least that will help us in several ways. So here is the potentials. The potentials of most of these African countries. You can see that this is the percentage of cement that can be replaced by each of these. At least we just look at about 4 biomaterial. We have granite ash, rice husk ash, maize cob ash, and cassava peel ash. And the overall percentage that we can, for it in Guinea, with this biomaterial, Guinea has a potential of replacing the cement consumption by over 5.9%. Though it's relatively small, but at the same time, it's also going to have a lot of impact if this is continued. Definitely, if this is also achieved and it is adopted, then it will also promote the agricultural business in most of these countries. It is win-win in all. If you use it, the more of it we use, the more of that will be, the farmers will be more encouraged. I would like to use a particular case of the cassava peel. Yes, cassava peel, cassava, like in some other country, we call it manioc, we call it yuca, is a source of food for about 500 million people in the world, and it serves as a food for 80% of the people in sub-Saharan Africa. It looks like a yam, and when it is processed, the peels is removed, and then the dump peels, they become another menace in the society. And the global production of this cassava peel, we have about 60% of the production in Africa. Yes, this is on this basis that we were able to give. We have a particular a project we call Local Care Project, which is sponsored by German Ministry of Education and Research, with my colleague Wolfram. We are together award this project. And then we know that Africa is cassava is almost everywhere. You can see the production of cassava in Africa compared to any other part of the country. So which is showing that cassava is a potential material that can be explored in terms of construction. So in Nigeria, the more the population in growth, there is a link between the population and cassava production. So presently we have, you can produce varieties of food from cassava. You can have the dry cassava, we have the wet cassava, you can produce gari, we have cassava shinshin. All of these are delicacies that we can also produce from cassava. But in the course of producing this, a lot of waste are being generated. This is the value chain, the current value chain that we are having in the cassava. In the cassava industry, we have the cassava, we can produce starch from here. We have the cassava peels, chips, and pellets. So while doing this, waste is being, peels and pulps are produced. Though animal feed, they are being used to feed animal, they can use it to produce compost or mushrooms. But the technology to produce this too is far, far expensive. But even because of the content of the hydrocyanic acid in cassava or the cassava peel, there is a limitation to which what animal can be able to take. So because of that, that is why we are saying that it is becoming a waste, and this is where the local care really want to really utilize this waste. So this is just when the farmer produce, you peel, then we have the peel which is already been dumped as a waste, and then you get the food. But this waste can be used in different ways. We can extract the starch from it, which can be used in chemical, in construction industry. The remaining peels can be burnt to burn clay, that is to produce a burnt clay, which will also be used. The ash that is coming from here can be used to replace as cement. So this is the low emission processing of this bio waste. Yes, apart from the mechanical properties that we're able to use to enhance the properties of concrete, environmentally, we can reduce the landfill, we can reduce pollution, we can also reduce the salinity effect, because a lot of bad odor exude from any dump site for cassava peel because of the obnoxious odor that comes from there. Nobody will be willing to build around those places. So those lands where they are building, they are dumping this waste will be used for another another beneficial use. So we have been doing a lot of advocacy on this. We have been doing a lot of educational programs to really teach students, to really teach the stakeholders. We have a lot of seminars on this. So very soon, hopefully by the end of this year, there will be a pilot structure which is built from the cassava concrete for the whole world to see, and then to know that this is very workable. So these are other agro-value cost saving in concrete. If you use agro-value, we check with the salinity effect, it save costs in managing this reduced population. improve local livelihood, because more of the farmers who are producing most of these agricultural byproducts, they will be encouraged to produce more. So this is one of the reasons why most of the researchers in African countries came together to develop, to form to develop a proposal for a technical committee of RILEM, which is use of agro-based materials as cementitious additions in concrete and cement-based materials. The chair of that committee is Professor Said Kana from Algeria, and my humble brother, my friend, Dr. Mike Otiene is the deputy chair and the secretary of the committee. We had our inaugural meeting, yes, in Cameroon 2017. This is the picture. So this technical committee has a potential to bring together at least the African scholars, so that we'll be able to develop the potentials we have in Africa, especially in the use of the bio-based material. A lot of publications have been, we have a lot of materials that have been published in this area to really give it a global view. So where do we go from here? There is need to reposition institutions to serve their mandates. We need to strengthen intra-African research collaboration. This is very, very important for the continent. Yes, we need colleagues from outside the continent, but there is need to really strengthen the African intra-Africa research collaboration. The researchers in Africa, we should come together, and we must also domesticate African research for our development. This is also very important. We promote evidence-based solutions to today's most pressing developmental challenges. Then, conclusion. Bio-waste are available in abundance, especially in Africa, which are still grossly underutilized. We can utilize it for our beneficial use. Greater opportunities are abound in the bio-waste. Utilizing bio-waste guarantees sustainable construction. And if government key into the researches that are coming from the university or from the research institute, then definitely this will also give some level of confidence in this. And then regional and international collaboration are required for meaningful achievement. Just like this particular program is more or less, it's an international collaboration where researchers from different parts of the world will come together, and then we support ourselves to really have a world that we desire. So I acknowledge the Ministry of Federal Ministry of Education and Research, Germany, BAM, where we did some of the experimental studies, then my university, and then my colleague Wolfram. So thank you so much. I really appreciate the opportunity given to me. I appreciate Lucas and then Joseph. Once again, thank you for the listening attention.
Thank you very, very much, Carla, for the wonderful presentation. Indeed, it has been very interesting and quite informative. I will request the participants, just in case you've got some questions, you can always type them at the Q&A section of the platform. And I believe Carla will be glad to answer them. At the moment, because we are behind the schedule, I wish to take this opportunity to invite the next speaker, Jackson Wachira. We are glad to have you here. He's one of my academic mentors, and it's my privilege to welcome him. Dr. Jackson Wachira is an established scholar and a university administrator. He has a Master of Science and a PhD in chemistry, specializing in cement chemistry, with the following as key areas of interest. One is the use of non-conventional building materials, including lime and pozzolana cements, substitution of ordinary Portland cement with low-cost cement materials, use of self-repairing concrete or mortar by incorporating bacteria in concrete, chemical kinetics with key interest in adsorption and the degradation of fertilizer in farming and degradation of waters, with regard to mosquito breeding waters and adsorption of key elements in plants, reuse of industrial sludge with key interest in cooking and cosmetic oil sludge. Mutengi has been a dean of various schools at the university and now a registrar in charge of academic research and extension. He has won several research and development grants, including the Global Challenges and Networking Fund, the National Council for Science and Technology Innovation, National Research Fund, British Council Scholarship Grants, among others. So it is my privilege and honor to welcome to give us his presentation. Welcome.
Thank you very much, Joseph, for that introduction. I'm not sure in my presentation.
Not yet.
Are you able to see my presentation?
Not yet. Maybe you can still load it.
Okay, allow me to share in a minute. I'll share my entire screen. I hope now you can see it.
Just maybe you can click the presentation mode. Perfect.
That is good now.
Yes, that's okay.
Thank you very much, members, for the chance and the invitation to the conference. I must really appreciate the two presenters who have been ahead of me, who have actually introduced the aspects of cement and construction. Basically, as Kolowole has said, is that the greener the cement is, the better. We've also been Kolowole has talked about little fascinating information, has given us little fascinating information with respect to cement. I've had bits about Dangote cement, the Lafarge, the Portland Pozzolana cement and the like. And I'm happy to see that they are quite in use in Africa and in many countries. But needless to say, the biggest challenge that we face with respect to cement and infrastructure, as has been said, that cement actually is being used globally at 90%. The 90% consumption of cement is in Africa. The biggest challenge that we have with respect to use of cement are related to the natural problems that we face in Africa. Among them is a water shortage, technical expertise, and now the effect of the global warming with respect to climate change. That is not my topic, but those are from use of cement as a major infrastructural building material. When you talk about lack of water or deficiency of water or potable water in Africa, what that means is that the little water that is available and can be used for cement-based construction is actually waste water. And this wastewater presents a lot of problems. We all know that, well, my background is in chemistry, so I can talk so much about the waters that we use, ordinarily what we call mixed water while we are preparing cement. You find that that water might be having chlorides, might be having sulfates, might be having even magnesium components. And these are extremely harmful agents with respect to construction of cement-based structures. You also get what we call sulfur-producing bacteria. I'll be talking about them when I'm talking about the microbially induced deterioration. For introductory purposes, the durability of cement is basically dependent on the pore structure. Not to ignore the other physicochemical parameters of cement, but the most important aspects of any cement-based structure is its pore structure. The more the porous it is, the more it is prone to aggressive agents attack. The more porous it is, the less the physical chemical properties it possesses. The more porous it is, the more easily degraded it is. And we have a lot of microorganisms in the soil and water that we can use to be able to improve the physical chemical properties of the cement-based structure. In our research, or the ongoing research, that Joseph is part of, and about a team of about 15 scholars in Kenya, outside Kenya, and I'm happy to see that we are now pushing Agenda Africa for collaboration between researchers. We have basically been asking ourselves the hard questions. Why do we have to go to the conventional methods of repairing concrete? I've talked about the use of the mixed water that degrades cement. I've talked about the technical deficiency in Africa with respect to construction. So how do we repair this concrete? So the biggest question is, can we be able to have self-healing or self-repairing cement or self-repairing structure? And we have been able to explore this using the soil microorganism, and specifically the bacteria that exists in soil, therefore telling you that those bacteria can be used in the structure. And the bacteria that we have used in our research have mainly been chemical parts of the structure or simulate degradation of the same and then cause to repair the same. The beneficiaries you're calling the microbially induced calcite precipitating bacteria, the MICP, and the ones that cause deterioration are the one we call the microbially induced deteriorating bacteria. When you use MICP, most important advantage of it is that it is able to detect that there is a default that is occurring in your concrete, and it initiates itself and repairs the concrete, perhaps without even the knowledge of the people or the technocrats around. The MICP process, as I said, I'm a chemist with a lot of interest in cement technology, as has been said. Basically, from a chemistry point of view, we look at the presence of feed, the urea. What is displayed here is the first compound here, how it decomposes. Our interest is not this. It's not the first equation, but the second equation where we get the carbonic acid, the H2CO3. And the third equation that introduces the very alkaline nature of the cement. It aggregates or it improves on the alkalinity of cement. And the fourth reaction, which introduces the carbanium, the carbonate ion. And these carbonate ions, once you have them, it means that you'll be able to generate the free carbonates, which on the bacterial cell wall is attached because of its charge. Ordinarily, bacterial cells have got negative or sometimes even positive charge, which can be able to attract. Once it is attracted to the bacterial cell wall, it is precipitated by calcium that is around the bacteria in cement. Of course, you know the main constituent of cement is basically the calcium silicates. Therefore, it has a lot of calcium. So as long as you have calcium in your cement, which ordinarily would appear, and then you introduce a bacteria and give it a little bit of feed, you're talking about micrograms per tons of cement. You'll be able to get the calcium carbonate precipitate. This calcium carbonate precipitate that occurs inside the cement structure heals, or it is able to be precipitated on top of a crack within the cement structure, whether it is interior, deep inside the concrete, or near the periphery of the concrete. And as it is precipitated, three things that happen. Number one, it fills any pore or crack within the cement structure. Number two, if it is precipitated between the various component hydrated phases of cement, it interlinks them. For example, if it is precipitated between the calcium silicate hydrates, I'm saying so because I believe our audience understands the construction industry a bit, and the calcium aluminosilicate hydrates, it interlinks them, thereby introducing new linkages that enhance cement. Thirdly, it introduces the calcium carbonate aspects that are able now to have more cementitious material within the structure. And this is what you're saying is a sediment coating and a bridge is formed sequentially around and between particles, strengthening or increasing the particle linkages. That was about the beneficial bacteria. But when you talk about the degrading bacteria, the one that disintegrates concrete, and we see this in a lot of our sewerage systems, you have the sulfur oxidizing bacteria, which basically plays around with the sulfates in the environment. And the worst part is when it is able to oxidize the hydrogen sulfide, making it converting it into the biogenic sulfuric acid. This biogenic sulfuric acid here is very, very, very dangerous. The sulfate here, although you would have expected that this sulfate can ordinarily become a sulfuric acid in nature, if, and not just if, we ordinarily know that hydrated cement has a very high alkalinity. The pH is very alkaline. And therefore, these sulfates would ordinarily exist as precipitates, either as sodium sulfate, which are soluble, or calcium sulfates, or any other alkali and alkali metal sulfates. But when you introduce the sulfur oxidizing bacteria, what happens is that it is immediately converted into the hydrogen sulfide, and then the hydrogen sulfide reacts now with water, oxygen in the environment to convert it to sulfuric acid. That sulfuric acid starts now attacking the most the portlandite, or the calcium hydroxide that is produced by the hydrated cement, forming the calcium sulfate or the hydrated gypsum, which continues to react with the hydrated calcium aluminite, forming the expansive vetrigate. And these are the cracks that you start seeing when you have sulfates in the environment of concrete. Basically, it is this, what we call the vetrigate. That is basically the chemistry behind what I'm talking about. And what are our research directions? The first thing is to evaluate or see how we can be able to improve the physical chemical performance of cement. Talking about the compressive strength, the flexural strength, the porosity, the absorptibility of the concrete by use of that bacteria. But further, we want to investigate and see what specifically does this bacteria, the other degrading bacteria, affect the performance of cement or the mortar. And then can we use number one to repair number two? So this is basically a methodology that we are following in the laboratory for the last 1 decade. We have basically been using this. We have the cement, the sand, the standard sand, and then we prepare the microbial solutions with respect to that standard, after which we make the mortar prisms. These mortar prisms, we either make them using the bacteria solutions that we have prepared from here, or we prepare them using the distilled water, and then cure them in either the distilled water or cure them in the bacteria solution. Once we cure them either in distilled water or in a bacteria solution, these are just simulating the true environment. We look at their microstructure using scanning electron microscope, the XRD, we make EDX analysis, we check on diffusivity of the aggressive agents, basically the chlorides and the sulfates. We also look at the water absorption and sorptivity coefficients. And more interesting is we look at the physical performance, which is basically the strength in terms of the compressive or the flexural strength. We also ask ourselves, does this affect the setting time of the cement, basically by just looking at the fresh paste? And basically how we incorporate bacteria into the mortar. We have not really gone into concrete because you know the dynamics of concrete. We just get the bacterial cultures and then we grow them as per the specifications. We use, as we said, our mixed waters in Africa have challenges depending on the water, but in this time we're just using distilled water and the bacteria solution. We have the control experiments where OPC and PC are prepared using distilled water as a mixed media. But the experimental samples, we prepare the mortar prism using the microbial solution and cure them either in bacteria solution or in distilled water, which are the curing regimes. For MID, that is a disintegrating, we have the mortar that was prepared using the bacteria solution as a mixed water, either cured in bacteria solution or distilled water, subjected for 28 days. Then after that, we change the curing regime and put the bacteria solution as a curing regime. So these are just the bacteria that we have used in our investigation that are beneficial, the bacillus and the megatherium, the sphaericus and the megatherium. And then we have the deteriorating ones, the stachea, and the like. All these are bacteria that we have used in our investigation. Of course, we've investigated on their effect on the setting time, the normal consistency and soundness. And what is important is that the beneficial bacteria do not affect the setting, the normal and soundness performance significantly. But when you talk about the deteriorating, especially the stachea, we have the problem of production of the sulfate-based compound, and therefore causing a delay in the setting time, either initial or final, and also, of course, affecting the soundness in a few, especially on the OPC, which is basically quite. These are some of the micrographs for the beneficial bacteria. And when you do the micrograph, when you do the same analysis, what you see is that you see a lot of calcium carbonate precipitation and very good masses of the calcium silicate hydrate. This is very impressive for cement structures or mortars or concrete structures, because this enhances strength and is able to reduce the pore structure. Of course, it reduces sorptivity of cement and all the negative aspects of mortar. This is the first one was when we use the Lysobas bacteria. One of the beneficial, we check on the other one, the BF, and you see the voids really reduced. The etrigites very, very little, but you see a lot of the carbonate precipitated, the calcium silicate hydrates, and the voids are quite low. And this basically attributed to a more dense concrete, a more refined and a less permeable mortar matrix. This is basically by this four bacteria, the Bacillus sphaericus, the Bacillus megatherium, the Bacillus coni, and the Bacillus flexus. But now when you look at the biodegrading, bacteria, specifically stachea, what we find massive, if you see these needle-like structures here, these are the destructive compounds, the etrigites, that have been formed as a result of the sulfate that you are seeing being produced by the bacteria, causing the formation of the calcium sulfate, which reacts with the calcium aluminate hydrate, giving us a lot of, you see so much of the etrigites in this structure, the needle-like, so much. You look in between here, and this even tells you the porosity has really increased. You find very limited, again, amount of calcium hydroxide, the Portlandite, which is very important with respect to the pore structure, the pH of the pore water. But you see, it has been so much reduced within this concrete, we just find some basins of it. And one causing a rebar, or that is a rebar, is at risk of it even undergoing corrosion, because of course, you know, the Pabix diagram will always present protected ion in the high regions of the pH above 11. But when you have Portlandite washed as much as has been seen here, then it means that the rebar is not protected. And then this is just the chemistry foundation of what I've just been saying. We looked at the XRD. What is more important is that we find new compounds being introduced, the bavenite. Bavenite was traditionally a very good cementitious material, but because of beryllium component in it, it has received very little attention because beryllium is cancerous, so we don't really, but it's a very good, strong cementitious material. But we see it being produced when we have the bacteria. Our investigation is whether it was introduced as a bacteria feed or from the pozzolana. We are still investigating that. But we see a lot of other compounds, the daylight. You can see the increase with when you have OPC, you have the calcite, the calcium carbonate that I was talking about. You see when it is just OPC in water and water, you have very limited. But when you have in the either of the bacteria, you see the significant increase in the same. This is a matter of, in all cases of our treatment of the cement with the beneficial bacteria, there was significant, or there was appreciable increase in compressive strength, as well as also the flexural strength. And you can see at 28 days, we're talking about in 2 digits, we're talking about the 56th day, you're talking about almost 15% plus increase in compressive strength of the cement, which is very important. But when we introduced the bacteria, the degrading bacteria, of course, we had our OPC as control, the blue one here. You can see it increases up to the 28th day from the 2nd day, the 7th day, and the 20th day. Of course, OPC, 20th day of curing is almost 90% cured. So you don't expect significant change at above 28 days. But what you observe when we introduced our degrading bacteria, the first few days, 7 days, 15 days, the degradation is not appreciable. And it's not appreciable because the Portlandite is reacting with the sulfuric acid being produced. It's trying to neutralize as much as the sulfuric acid being produced. But with the time, the Portlandite is exhausted. And if you remember showing you that we're only remaining with small basins of Portlandite, now any other resultant produced sulfuric acid starts eating into the cement. And that's why you see now there is that reduction. You can see the comparison between the OPC and the other ones, that this was the one that treated in water, but these ones are the ones with the deteriorating bacteria. And it goes on and on as the days are going, that the degradation is seen. Same case here with the Portland pozzolana cement, the substituted cement. You see the same story. We asked ourselves, what is the effect of this degradation with respect to OPC and PPC? And what we noted is that ordinarily PPC is resists a bit, and you can see the reduction in the degradation is more pronounced in OPC. The first two, sorry, you cannot see here, these two, but you can see in OPC, the degradation is quite high, 28 days, and the days as they are going, the degradation is becoming more and more. But when you look at the last two here, the degradation is not as much pronounced as in these first two. Of course, the last is more pronounced because you have Stakea that was used as the mixed water, and Stakea solution, the degrading bacteria, as the curing regime. We asked ourselves, can we repair this concrete here that is being degraded using bacteria? And this is what we were getting. The green one, the green all along, the first one, is the OPC that was cured in water. And then the second one is the OPC, the blue one is OPC that was mixed with water and cured in the deteriorating bacteria, and so forth and so forth. Then we subjected the 28 cured, all these ones cured at 28 days, we subjected them in further 28 days curing using the beneficial bacteria as a curing regime. And what we observed was that as the days go, you find that there is some sort of repair which is now more pronounced when we have the graph summarized here. This is just the biodegraded, continued curing in water, and then we continued curing it in the beneficial bacteria, and you can see there was a sharp increase in compressive strength at the 50-60 day, which is quite promising. And when we looked at the repair, the SEM of the repaired concrete or the remediated concrete, the Portlandite were not as pronounced. If you remember the Portlandite, the Etrigite, sorry, the Etrigite were the needle-like. If you remember the structure that we were seeing, we had a lot of this Etrigite massively distributed all here. But now we are seeing a different story. The Etrigite is so few, but we have massive calcium carbonate. This is very important because it seals the voids that we were seeing, the calcium carbonate. It cross-links the few remaining the few remaining the compressive strength or the strength of the cement and also the physical performance of the cement. This is remediated by a different bacteria. The same story. You see very limited voids. There's a lot of repair. There's a lot of sealing of the voids by the calcium carbonate. Massive calcium silicate hydrate again starting to be seen because of the rehydration of the residual cements. And these are the conclusions that we're able to draw, that MICP improves on the physical performance of the cement. MICP introduces more new materials, and we have the degrading bacteria, and then we can be able to use the beneficial bacteria to remediate the failed concrete. Thank you very much. Back to you, Joseph. Back to you, Joseph.
Okay, thanks. Thanks for the talk. I think this session is now ending. Let me. Okay. And Joseph, I don't know if you're there.
Yes, I'm there, Luca. Thank you so much. I think you can. We want to thank the presenter who has just made, that is Jackson, who has made his presentation, and we hope to take a break, and we resume what time? Maybe you can guide us on that, Luca.
I'd say perhaps in 1 hour time.
Yes, that will be 20 minutes past.
You mean 1 hour time?
Yes.
Yeah, 1 hour from now. I'd say we're slightly behind schedule.
Okay.
So, yeah, it will be for the reference time, say, in, yeah, 11:20 at the reference time.
So we'll come back 11:20 or 12:20.
Yeah, it's depending on your time zone.
Yeah.
Okay.
Thank you for your keen participation in the morning session, and we look forward to meet you in the other session.
Yeah, want to ask the attendees to log in again. We will end the meeting for the moment, and then we in an hour we will resume it. So we will everyone needs to log in again. Okay, thank you. See you later.
Bye.